Good morning. I hope that you are finding yourselves nice and safe for week 2. Guys, this week we're going to do 2 days worth of notes. We're going to do section 4.4, and then we're going to do section 4.6. And both those sections are going to be very, very similar to each other, so it's a good idea to do those two. Guys, make sure that you're working on the homework, you're getting the notes completed. I have a feeling that we might not see each other again, and a lot of this stuff is going to be due after spring break, so I don't want everything to be pushed on you at just one time. So try to get this stuff done. I'm not trying to give you too much throughout these weeks, but just make sure that you're getting the homework done and making sure that you get that take-home quiz. All right, well, today we're going to talk about section 4.4, undetermined coefficients, the superposition approach. And so basically what we're going to have here again is we're going to have the same type of differential equation. We're going to have a differential equation of this form where all of our a's are going to be constant. So again, all of the constants of our differential all of our coefficients are going to be constants, but instead of this being homogeneous, it's actually going to be set equal to a function, g of x. So because it's set equal to a function, it's going to be non-homogeneous or non-homogeneous differential equation. So these are what we assume when we look at this, that all of our coefficients are going to be constants, and that what our g of x is going to be either just a constant k. It could be a polynomial function such as x squared plus 2x plus 3. It could be an exponential function like e to the alpha x. Or it could be a sine or cosine function, sine of b of x or sine of beta x or cosine beta x. Or it could be a sum of these functions, a polynomial and an exponential, or an exponential and a sine cosine, or products of those functions. If it's not those, then we're not going to be able to do it during this class. So here are some examples of a combination. This is with subtraction of sine, and here you have a polynomial function times an exponential function, and here you have an exponential function with addition of a cosine. Some things that g of x cannot be are going to be natural log of x, 1 over x in the denominator, tangent of x, and inverse sine of x. So what we're going to do, and why this is called undetermined coefficients, is that if our g of x is of any of these forms, say it's 1, then what we're going to make our y a p, our particular solution. Again, we're going to have a particular solution because this is a homogeneous, so we're going to have a complementary solution and a particular solution. Complementary comes from non-homogeneous. The particular comes from the homogeneous. That we're going to make our particular solutions just a if it's k. Now, if it's a linear equation, 5x plus 7, then our particular solution is going to be ax plus b. All these a's, b's, c's, these are our coefficients. That's why it's called undetermined coefficients. We're going to find out what these a's, b's, and c's are. Here we have a quadratic, so now we're going to make that ax squared plus bx plus c, and so forth. So if we have, a polynomial of the third degree, it's going to be ax cubed plus bx squared plus cx plus c. This is going to happen for all the polynomials. So if we add x to the fourth, it'd start off with ax to the fourth, and then go all the way to d. I'm sorry, not d. I would make this plus a d, not e. Go all the way to e. Now, if we have sine of 4x or cosine of 4x, when we take the derivative of that, it could go to sine and cosine. So anytime we just have sine or cosine, we're going to incorporate both of those. So if I have sine of 4x, it's going to be a cosine of 4x plus b sine of 4x. And even if I have cosine of 4x, it's going to be a cosine 4x plus b sine 4x. Now, exponentials are just going to be a e to the f to the 5x. And then here we have a combination. We have a linear equation times an exponential. So if this happens, this part is going to take the form of ax plus b, And then we're just going to multiply that by e to the 5x, where this takes place of that coefficient right there. Same thing with the x squared. And then now if we have sine times an exponential, what we're going to be able to have is the same type of combination, where e to the 3x is going to go to both the cosine and the sine. If we have the x squared, now this is going to go to both the sine and the cosine. Ax squared plus bx plus c. And then the next one, though, isn't going to be ax squared. It's going to be ex squared plus fx plus g of sine of 4x. And then here you have like a combination of both. So you're just going to stick this with both of those. All right. All right, so let's go ahead and get to our first one. And what we would do is we want to solve the given differential equation. Now, since this is non-homogeneous, our solution is going to be y equals y sub c plus y sub p, where y sub p is the particular, y sub c is the complementary. Now, last section you were taught how to find the y sub c. That's when we actually take our differential equation, y double prime plus y prime and a 6y, and we set that equal to 0. And then we're going to solve like we did last time, where we're going to make this m squared plus m minus 6 equals 0. We're going to solve that, and we're going to find our m. Now again, that's going to turn into m minus 2 and m plus 3. Set that equal to 0. So our m's are going to be m equals 2 and negative 3. So then our complementary y sub c is just going to be c sub 1 e to the 2x plus c sub 2 e to the negative 3x. Any questions? I'm sorry, they can't ask questions. All right, so that's how we get our complementary solution. Now, to find our particular, we look at what our g of x is. What is the other side? So it's 2x. So this is of the form, this is just a linear equation. So I'm going to go back up here, and I'm going to pick where it's 5x plus 7, so it's a first degree polynomial, and I'm going to set y sub p is equal to ax plus b. And now we believe this to be a solution. To find out if this is a solution, I'm going to take the first derivative and the second derivative so I can plug this in to my differential equation. So I'm going to take y sub prime of p, and that's just going to be a. And I'm going to do y double prime of p, and that's just going to be 0. And now I'm going to substitute this in. So y double prime is going to be 0 plus y prime, which is a minus 6 times y, which is ax plus b. And I'm going to set that equal to 2x. Now, what we're going to do is we're going to try to combine everything that we can so we can keep it in the form of ax plus b. So I'm going to distribute my negative 6 and get a minus 6ax minus 6b, and that equals 2x. And now I'm going to rearrange this in descending order in terms of my x's. And so I get negative 6ax plus a minus 6b equals 2x. And now we're going to match these with the coefficients. Because this coefficient for the x here is minus 6a, this matches up with that coefficient, which is going to be 2, because they're both with the x's. Now, a minus 6b is just a constant, and the constant over here, we don't have it, so I can say plus 0. So this part, a minus 6b, I'm going to set that equal to 0. And so when I do that, I'm going to get negative 6a is equal to 2, and I solve for a. A is going to equal negative 1/3. And now that I found a, I can go to this equation, which is a minus 6b equals 0. Well, I know what a is. A is negative 1/3 minus 6b equals 0. I bring over the 1/3, so I get negative 6b equals positive 1/3. I multiply or divide by negative 6 to both sides, and I get b is equal to negative 1/18. And now I'm going to go ahead and plug this in to my equation, and we're going to get y is equal to the complementary plus the particular, which our a is now negative 1/3, so it's going to be negative 1/3 x plus our b, which is negative 1/18. And I can write that better to be c sub 1 e to the 2x plus c sub 2 e to the negative 3x minus 1/3 x minus 1/18. And there's the solution to that differential equation.